So I believe all of you are doing good and we can start, right? We're good to start. Great. Mm, so let me know if what we were there. Okay. So I believe we have been through arrays, indexing, slicing. This part we were there in NumPy array, right? So I'll create some NumPy array and then let's explore. Okay. Again, the same indexing. Indexing, I believe, is being done. So let's see the slicing part, right? So let's just quickly revise this stuff. So to actually use the capability of NumPy, you have to import NumPy like this. Import NumPy as NP. Say visible even. So to get initialized, it will take some time. Yeah, it's imported in my environment. Okay, folks. Yeah, we dot say for example range. Let me use a range only, and let me use just 10 here. So this would be my A, and B would be say for example np dot range, and I would take 24 for that matter, or reshape is 4,6. 24 would be big. So say for example 12 only again, right? Reshape 3,4. C is equal to np dot range discount 3,3. Print D. Right. Now the thing is, uh, if I need to get this, if I need to get this, right? 6. So how would I get this? What would the index? So I believe it will be a 7th place, right? So 6 would be at the 6th place, sorry, because 0 index is also there. 6, right? And that, right? That makes it somewhat interesting, right? So this is my A array. If I need to fetch this, right? What would be the index? Yes, folks. Let me know in the chat box. If I need to fetch 18. Index. Yes, folks in the chat box, let me know. 4th, right? You can start with a 0 because indexing start in Python with 0, unlike SQL. In mostly all of the, you will see the languages, high level language, it's start from 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Yes. So A square bracket 4. This is syntax. You'll get it in. Agree or not? And can you see in collab environment, the default integer is integer 64. 64. We have not defined it. The default data type is integer, and of integer, the default data type of integer is integer 64. There are other integer as well, which I'll show you, but this is an observation. Agree or not? Now, let's fetch the 6 of this, which we have discussed. What is the index of 6 of this? Quickly, guys, quickly. Okay. One comma two. Yes, exactly. So the index of this would be first row. This is the zeroth row, right? This is the first row. This is the second row. So first row and the zero column, first column, second column, right? Now, in fact, it's not about just this only. You can see this. If I need to fetch the second entire row, right? Okay, we have not discussed this. If I have to discuss the second entire row, so how I would go for this second entire row? Somewhat I'm just moving to slicing. Okay, let's hold on for that. If not to move slicing for this, uh, let's see the C. C is this, right? Now this is a three-dimensional, right? Of course, three-dimensional. Now if I need to fetch this and three-dimensional, as in there are three arrays of two dimension. True or not? Three arrays of two dimension. If I need to fetch the second array, just the second array, how I can fetch it? What if I need to fetch the first array? How I can fetch it? You see it? See, if I just put the one, can you see this? You get the entire second array. How many of you got it? Yes. Just need to put the address of that first index, right? So here you can see that the row is actually first element is just telling you the which sheet is this. There are three sheets. Which sheet is this? Which array is this? Now think deeply. If you need to fetch 11, right? First fetch this sheet, which is C1. Agree or not? Even if you go for C0, I believe you can feel it. But you would get the this one, this array. Agree or not? This array. Agree? Now the thing is, if in this array, in this entire array, I need to fetch 11. First, I would fetch the sheet, second sheet. Index is 1, right? Then I would fetch its row. Then it's just like 2D array. First, I would fetch the second sheet. Then I would fetch the row, which is 0. Then the column 2. Agree or not? Then it's just like the 2D array. How I was doing with the 2D array, right? How we were doing with the 2D array. Where we did the 2D array? There. Can you see this? There we did the 2D array. Same. First, fetch the sheet 11. Can you see this? 11. Let me know if you can see 11. And if you got the logic, very good, very good. If you got the logic, everyone just give me a thumbs up if you got the logic. Yeah, folks. Now the thing is, we'll move to the slicing part, right? Now, A. There was an array like A, right? If you need to fetch few elements, right? Indexing is just one element. Slicing is many elements. You are just taking part. Indexing is just one point you're taking, right? So slicing, if you want to fetch from the first index to the seventh index, so the same you did with the list, right? Is to. You have to put this symbol like is to. Can you see this? From the 1 to the 7th index, right? For 1D, it's very easy. Just like the list, right? For 2D, it was this. Let's try to do the same. Say, for example, I want, you know, the entire first row. First row is in 4, 5, 6. Index wise, I'm saying first row. I want entire this. So first of all, what will be the row number? Yes, folks, what will be the row number? 1, right? If yes, What would be the column number? There is a specific column number of every column. Row number is 1, right or not? This is 0, this is 1. Index as in, row number as in, I'm talking about the index, 1. What is the column number? Every column. For every column, just put is 2. Okay. Now the thing is, case intelligence is, right, is 2. Is 2 is like every column. Now see, true or not? Because even in, when you're just defining is 2, it's just like you're defining everything. Just go for everything. Like for A, if you do not define, if you just put is 2, so what does it mean? Every element. You're not defining starting, you're not defining ending. So it will take every 0, it will take entire length, right? It will take from the 0 and it would stop till the end. Agree or not? So you have not here specify the starting and end of column. Of column. So it would take first row and every column. So the entire row would come. True or not? Don't worry, we'll practice. Let's go for the, if I just want only the third row here, right? If I just want only third row here, then it would be, can you tell me in the chat box? Only third row. Only third row, exact third row. Hmm. So for third row, what is the index of the third row? 2, right? Yes, exactly. Try over your machine as well. It would for sure give you Siri 2 is 2, right? The entire third row. Now the thing is, if you want this column, 2, 6, 10 column, 2, 6, 10 column, how would you go for? Now this time I'm going for a column. So if you are going for a particular column, can you see this? What does that mean? How many rows I'm taking? Every row. In a particular column, you're bothered about every row, right or not? If I'm talking about this row, column. So I just mentioning column is unique. Column is fixed, but row is every row. Yes. So I believe you got it, right? So it would be, see the see the logic, see the science. And it's just like, you know, though if time would allow, I'll show you how to learn from the first principle, like you are inventing it. But still we can have the thought process, right? It's true. So every row and the second column, right? 2, 6, 10. Agree? Now let's do more into it. Okay. Uh, Let me take a bigger array and there will play. We'll practice. You know, arrange. Say was 24, comma reshape 6, comma 4, 6, comma 4. So it is going to be a big array, right? Now in that, I want this, this, this. Can you see this? First, second, and third. These rows. How to go for this? Now see here. So here I need to specify. So 0, right? And this is my array. Uh, this is my array. And this is my array, right? 0 is to everything with a jump of 2, right? Comma, every column. That's it. Now just check what just had happened. Right? What just had happened? Break it. So in case of A was 1D. A was 1D. If I want only, this, and this and this. How I can go for this? A is 2. I would start from 0, 0 the text. I would end, do not mention the end. If you do not mention the end, it would take everything. But I would mention the jump. The last thing is starting, end, and jump. Jump is 2. Can you see this? So jump is second, or what do you call this? Step size or jump size. So it will start from there. Ending is not mentioned. Can you see this? After 0, nothing is mentioned. 0 is 2. I need to mention the ending. Do you don't know the length of the array? So let it be. If you don't mention the ending, it will take an entire. But you can mention jump. So it will take this, then from there a jump of 2. One jump is this, one jump is this, jump of 2. Can you feel that? If yes, give me a thumbs up. This is for 1D. I'll break it for 2D. Yes, for 1D, jump is okay. Jump is clear. Yes, 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 folks. Don't worry. I'll try to put this numpy like into your veins, right? Don't worry. Now for 2D, like this, D. I need to mention the rows or columns. When I want this row, this row, this row. Row is specific, column are every. We are taking every column. Agree or not? For the time being, column part, don't worry. Because column is like take every column. But row is like you have to specify. So we'll start from this row, then go for this row, then go for this row. Now it is like 0. Do not mention the endpoint, but mention the jump. Cool or not? So it will go from the 0th row, then a jump of 2, this row, then a jump of 2, this row. What do you think? And every column. And every column. Cool, guys? Let's take it to the next step. If you give me a thumbs up, then I'll take it to the next step. Okay. And pay attention, everyone. Just give your full. When you're learning it, give your full. Do not worry about anything. Forget everything. You should, it should be like, this is your game. This is you are the king, right? So you have to put you're the coolie. So you have to put your everything. Okay. Now I want this. 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 Now it looks different element. But our point is the logic. Our point is just to make it convenient. This is what engineers does. Solve a problem. May look very difficult for the other world, but you have to solve it. If there's a pattern. Cool guys. So let's tackle it. Let's tackle it. See the logic. Which rows I need, which columns I need. You need to break like this. Which rows you need? Rows though we have already seen. 0 is 2. Don't mention the end, but mention the jump. Right? But this time in column also, I need a jump. If where it went off, yeah. You can see the pattern. I don't need this column at this time because I need this and this only. Think yourself, I need a jump in column as well. Agree? In row as well, I need a jump. In column also, I need a jump. True? So I would, in column also, after comma is column. 0, I would go, okay. 0 is 2, do not mention the end, and jump of 2. Now see, cool or not? Achha, it was D. It was D, so I went for B. So let's go for D. Can you see this? 0, 8, 16, 2, 10, 18. Let me know, guys, if you got it. If you can feel it. So now the thing is you have to feel it in the real time. As this can look very bizarre. That's why I says pay your full attention. Okay. And now it is fine. If you got it, you'll get it for life. Now let's see this array. This array. Right. In this array, if I need this and this, shall we go for this? 9, 10, 11, 15, 16, 17. Right. Or before that, where is B? B is this. So you have to tell me one thing, right? Let's see if we can, tackle this. I need only the corner element. I need this corner element. Share me the logic in the chat box, guys. I want answers. Give me at least some good percentage of the answers in the class. I just need corner elements in the B array. What would be my logic? Folks, any answer? You can even answer that, confused. I don't know. I'm okay with that. Mhm. Good. Right. Good. Okay. 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 Anyone can give this entire syntax what he would put. He or she would put inside B. B as array. B as array. What you would gonna put inside B and as array. Now see here how to tackle it. I'll show it. You just pay attention. Now see. First of all, rows. The rows we want. First row and the second row. Right? You want to jump in rows. So 0 is 2, 2. This would give you the rows. Right? And the columns you want. Okay, we'll see. Now let's see. Column I want. This column should get included. Now see. This row I need and this row I need. First tackle row. Then column. This column I need. And then directly I need this column. So jump of 1, 2, 3, 3. Right? So for column 0 is 2 as in you're not defining the end. 3. So I was wondering any answer like this. So if not, but I believe you can feel it now. True? No worries, no worries. Even you can feel it at this moment. If it is a yes, cool. I believe now you want. Let me know if you want me to repeat or let me know if you got it. If you give me a thumbs up, I'll feel that you got it. Okay. So I'm great. Now let's see this. Now in this array, give me this row and this row. These elements I know. 9, 10, 11, 15, 16, 17. These element I want in this array. So now see, first of all, get the second array. Second array index is 1. Then in that second array, get the those element. And that is simply means rows. 0 I want. Then I want the second row. So the thing is, see, if I want these element, if I want these element, then I would start from this row and a jump of 2, right or not? I do not need to define the and, but I need to define the jump. Agree or not? Yes. So jump. And now what about the columns? Columns you don't need to worry about, every columns. Now just focus here in the second array only, right? Just take it as a single array. And here you don't need to define the columns. So it's 2, only it's 2. Cool or not? Cool or not? Now again, if it is cool, very cool, and give me these elements. Guys, this time give me this, 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 this. What would be us logic? These elements I want. Well, let's make it more better. This too you can do. So let's make it tough. This, this, this. I want these. Think over it. I want this, 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 this. These elements. How you would crack this problem? This works. If it is tough, though we have discussed a lot, we have solved a lot. If we just give you push, you can do it. Break it one by one, one by one. First get the arrays. Then inside the arrays, get the rows and columns. I want some answer actually. Folks. Mm, okay. First, let's get the array. Okay. First, let's get the array. So in this array, okay. See, first of all, I would get the array. So array is like I would start from the 0 and I would have a jump of 2 only, right? So ending is not this. So it would go from this to this. So it will skip the middle one, right? Middle array. So this one is for array. Second is for in those arrays, rows and columns. So what would be the rows? In every array, I have chosen with this, what I've chosen, first array, this is a 0th array, then a jump of 2, then this array, right? This would help me to select the array in 3D array, right or not? Now in those array, what are the rows and columns? So the second part would give me the rows and columns. So I need this row and then I need this row. Cool or not? So in those selected array, which number row is this? 0. And then, right? 0th row, 0th row, right? And then ending do not mention and the jump of 3, right? Jump of 3. then you would only get, you would start from there, feel it yourself, and a jump of 1, 2, 3. So it would only include the first, first row, first row of these two. I'll show it. I'll show this much. First, I'll show that part. I believe I need to show each line. Is two, is two. What it will give? The first array and the second index array. That simply means this array and this array. 0, 1, 2. Right? This is for array. Now in this, if I just define zeroth row, is 2, more than 2, 3. So it would only give me, now you go to each array. You start with the 0 index, have a jump of 3. So it would come out of this. Right or not? And see, it would take the first row of each array. Till here, how many of you are comfortable? Let me know. Yes, folks? Till here, how many of you are comfortable? If it's still not, I'll rewrite here. It is easy, na? Interesting as well. Just dealing with the array. It's fine. Then give me a thumbs up. Right. And then this would give this. Now here also, the third part is the column. I need this and this and this and this. Now simple, just define column with a jump of 2. So I just give column 0 is 2 and a jump of 2. As simple as that. If you all are comfortable with this, or you can, register it, digest it, then I believe slicing would never be a problem in NumPy for life. You'll never face a problem in slicing in NumPy arrays for life, right? And trust me, why I give so much time to it, because you would see people after long experience are also not comfortable in understanding these things, right? So fundamentals are not very fine with respect to the people. And if your fundamentals are not fine, you will never feel fine in the future as well. Agree? It's like, you will not get things like in depth. It is very important to get the depth of the things. Cool, guys. Give me a thumbs up if it is a yes. So slicing and indexing, we have touched a lot. Then I would like to go to the iteration. Can we do the iteration? Iteration as in for loop and all, like iteration. What happened when you go for iteration in arrays? That is a question, can come to your mind, because arrays you would say it's just like list. The data structure looks like list only. What actually happened? Okay, just a minute, guys. So for I in A, first one was A, na? 1D, print I. So if I just go for 1D array, so it is just going to take each element of 1D array, right? Which was A. B was 2D. What would happen if I iterate in B? Every element would come, or what? What is your thought process? What do you think? What can happen? I'll show you what would happen. It is not iterating each element, it would iterate row wise. So can you see this? For 1D array, you get each element like in list, right? For 2D array, it is not iterating element wise, it is iterating row wise. Your output is a row. Agree? It is iterating 3 times. 3 times. That is 3 rows it is iterating. If it is a yes, give me a thumbs up. It's just the nature of the NumPy. Just feel it, right? That's why I'm just stressing over these small things, but trust me, these are not small. They could make you think like mathematician, engineer for that matter. Let's see the 3D array. It was like C, I believe, for I and C. And I believe now at this moment you are mature enough to think what would happen. So it would iterate 2D array. So there are three 2D array. So it would iterate three times. One for this, one for this, one for this. Now, second question would come to your mind. What if in 2D array or 3D array, we want to iterate element wise? We want to fetch each element. Of course, we can do nested loops and all, but you might feel that any developer might have think of it in the past as well. Like we are thinking, yes, developer had thought over it, some development and developer, and there is a function for that as well, right? And for this, I believe for I in np dot idtr, what is the function name? It's not coming. And this is n dimension iteration and C. Then for example, B. For that, for first, let's go for the B. It is like, yes. Now can you see this? Easily you can iterate every elements of 2D array. In fact, for 3D array, for I in C, not C, and P dot, NDITR, C. Who do not? Right, folks? I believe this is fine till here. Easy. Now, there are some function in reshaping as well. Reshape, though I have shown you, there are more into reshape. Let's just see them as well. Reshape. So reshape we have already seen. You might have seen, right? So there are more function in reshape. First, let me show you the same one, simple one, which we have seen 24. So this would give you a 1D array of 24. Now, how you can make it a 2D array or 3D array? 3D array can be done. 24 is 6 comma 4. So 6, yeah, 3, 2, 2, 2. So this can be reshaped as 4 comma 6, right? So a 2D array. And this can also be reshaped as a 3D as well. To see the factors of 24. It can be like 3 rows, 2 comma 2. So 3 arrays of dimension 2 comma 2. Okay, this is 12. So my multiplication is wrong actually. So 3, this I need to make 4 or 2 comma 4. 8, 8, 6. Right. Cool or not? So this is reshape. Reshape we have already seen. There are more than reshape. There are transpose as well. So say for example, you have a simple B. B was like this, no? Yes. So B is, if I just give you a shape of B, can you tell me what is the shape of B? 3 comma 4, right or not? 3 rows, 4 column. What is the dimension of B? Dimension is 2D only. Agree? Because it is made of rows. So lines, something which is made of line is a plane, 2D. Something made of rows is a 2D array. Something made of many 2D array is 3D array. Cool or not? Something made of many planes is a 3D figure, right? Now, if I just do the transpose of this is your B and the transpose of B. There are two functions for this. The easy is this, B dot capital T. I believe it would run. Yeah. So transpose is 3 comma 4 becomes 4 comma 3. Right or not? Let me show you this dot shape. It would be 4 comma 3. 4 rows, 3 column. But transpose, I believe in schools you have seen what is a transpose. So this. If there are 3 rows, 4 columns, right? Then these rows will become columns. This is transpose. Agree? Give me a thumbs up. Then there is one more function. I would at this moment we have just seen how to just 1D array. We are making 1D array to 2D, 3D. But how to make 3D array or 2D array as 1D? So there's a very simple function for that, Ravel. Very important, right? In deep learning, you would use to flatten the arrays and all, right? V dot, if I just put Ravel, now see, okay, V dot Ravel. Can you see this? This is a 2D array. Now it make it a 3D array. C dot, this which was a 3D array, Ravel, 1D array. So Ravel makes multi-dimensional array as 1D array. If it is a yes, give me a thumbs up, guys. Till this stage, till this point, everything is fine. I hope you can feel the, you know, maybe this is at times can be confusing but interesting. They are interesting actually. I would not say confusing, right? Right. There are more concepts like stacking, horizontal stacking, vertical stacking, and not very tough with respect to these data structure. They keeps on coming. So just I'll take you some minutes of yours and show what they are. So you would see these stacking these things everywhere, whether you talk of Excel tables, whether you talk of SQL, whether you talk of pandas, NumPy. So my question is what they are actually in the first place. So excuse me, vertical stack. Vertical stack as in you have one array, right? Uh, you know, or even forget about the terminology, which is vertical, which is horizontal, whatsoever, right? One way of joining the table, okay, is this. If you have different columns of tables, so you can join horizontally. Horizontally, as in you will increase the depth, width. If you have the same number of column, you can join vertically, right or not? Uh, if you have two phones of same dimension, you can join them like this. Agree or not? Or vertically, because they would overlap completely. So this is if you have two objects like of the same shape, same number of columns. Shape here is I'm talking about the same columns. Then you can join this and this. What do you call this? Vertically, because height is increasing. Now see the concept. See the concept geometrically because height is increasing. So these all tables, it is not need to that they have same number of rows. But what is the mandatory condition? They need to have same number of columns. This has to be constant. This doesn't matter. This doesn't matter. This can be this. This can be this. This can be very large. But if you need to something vertically join something vertically, their width should be common, right? Their width should be constant. And vertically joining means their length, height would increase. And what is horizontally? Joining one thing horizontally, right? Now, thing is, if you want to join something horizontally, this is one. Can you see the number of the rows should be common? The number of rows should be constant, and number of columns can vary. If you agree with this, let me know. So this can vary number of columns, but this size should constant. And horizontally, if you add arrays or tables or anything, the width would increase. That's why it's called horizontally because it is spreading like horizontally. Cool, folks. So this is called the for the in NumPy the concept is called stacking. In NumPy, we call this concept as stacking. There's a function called stack for the same vertical stack, horizontal stack. So yeah, I believe the concept actually you got it, right? If you just want, I can create to table just to show you. But point here is uh, stacking, right? So A1, for example, np dot arrange and 12 dot reshape, right? 3,4 A2 would be np dot arrange 12,24 dot reshape 3,4, right? And, right. So these are the this p dot horizontal stacking. So I've taken dimension exactly equal for both of them. Edge stack, I believe. Edge stack, horizontal stack A1, comma A2. So horizontal stacking, their size would increase like horizontally, and their size would increase like widthwise. Takes one position argument. Something has changed. These things keep on happening, so don't worry about this. Right? Make sense now, guys? Same, you can go for the horizontal stacking. Not a big deal. If you got the concept, you can go likewise. In that same, you can go for the splitting as well. Now you can join like this, you can split like this. For this, you have horizontal split. For this, you have vertical split. So I believe it is fine. I given you the field. So it's not need to go to them each example. You can try it. Right, guys? If it is a yes, give me a thumbs up. Then I'll show you something else. Okay, folks. Great. Great with that. Now, mine, you know, last part of the session is I want to experiment. In fact, we should experiment with that. And experiment is as in we talked, NumPy is better, array is better, NumPy array is better than the list. And of course it is, right? In terms of speed, though list is heterogeneous, right? Of course, everything has its own utility, right? In real world also, let me know if you agree with this. In real world is like non-binary. What do you mean by non-binary? It's just like there is not a one size fit all, right? That's why we have so many algorithms for different situations. And though people used to tell that in physics, like there is going to be one theory of everything, which can encompass anything, everything in the universe, though it's not been till yet proven or any practical application of that, right? It's just more sort of fictional, or what do you call that? Fantasies, scientific fantasy, right? But still, what I believe is for different problems, we have multiple solutions. We have different solutions, and one solution is better than the other for a particular scenario, right? You might have seen it in the world as well. One one size fits all. This is not a case, right? Same for here. Till now, this is not the case. We have different data structure or different utilities, and we have to do, right? We have to go until unless we have a universal data structure, until unless we have a universal algorithm. So until unless we need to compare. Till then we need to compare. Okay. So let's compare. Let's see. Let's make an activity. List versus arrays. And we'll figure out by ourselves. So before it, I'll just put a big what do you call this, foundation or something? What do you call it in English? Before a story, you know, we call it bhumika. But what is bhumika in English? Before a story or before everything, you just put a bhumika in English. Anyone? Role. Prelude. Yeah. introduction, prelude. Prelude is a better word, like prelude in music and all. Yeah, introduction, prelude. So, right. Cool, guys. Shall we go for this? Let's check this. Right. I'll create a array. I'll create a list for that matter. And first, let's first take this speed test. And in fact, the speed test of list. Right. So I'll do an operation. Just a minute, everyone. I'll create a list. So I for I in range, say for example, 1 crore. So how many zeros in crores? Seven zeros. 3, 4, 5, 6, 7. This is one list. B is equal to another list. I for one in range 1. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I got two lists, right? Now what I would do, I would try to add these two lists, element by element, and then see the time, right? So let me import time as well here. So a module type I need to import. Right. Now there's an empty list. This, right? So let me just put a start time dot time. Okay. Till here things are fine now. No syntax error, I believe, because you can feel it. It can take more time, much time. Right. Now thing is, this is my starting point, and what is my actual time for this code execution? I will go for time dot time at this moment minus start time, right? So for list, if carrying out this operation, so list would take this much time, 1.47, right? I believe it is in seconds. Okay. So let's try to figure out it for the speed test for array. Well, take the array of the same size and do the same thing, right? So to create array for the same size, uh, numpy is being important, right? A is equal to np dot range 1, 2, 3, 4, 5, 6, 7. 7 is okay now, because I wanted to test should be like level playing field, right? And then np dot range 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right. A and B is in, right. C would be A plus B. So start time dot time, and C is equal to A plus B, because in array you can just directly sum it up, right? Let's see how much time it would take for you know it's to execute. 0.30. Now see this. Can you see this? There is a lot of difference between the two times. And what is the difference? Let's even check their scale. So say for example, I will just take 1.47. 20 divided by 0.30. Almost like 5 times faster, right? Of course, the situation you also get it is almost like 7, 8, 9 times faster. So in this activity, we have seen that our array is executing this thing as like 5 times faster. True guys. Though you just go for it and over your machines and all, sometimes it would be faster like anything. 60, 70, 90, like this times faster. Okay. I believe it should be more faster, 50 or something. Okay, try it again. Okay, maybe. Um, anyone you have tried and it's amazing. It's giving amazing results speed wise. Let me try again. 1.39. 1.39. Now you can see this time array perform better. 1.7, 8 times. Right. Likewise, I can would change the number and it can goes array can be faster like 50, 60 times. If it hang out with the if it settle with you guys, give me a thumbs up. If we're able to prove that arrays, numpy arrays are faster than Python list in build data structure. Then I'll show you the space thing. Cool guys. So what I did here, time.time is a module. You can get the time at that very moment. And I store that time while executing, while your code is executing, this moment time get registered. That, say for example, the Python interpreter took some seconds here. Then for this part where actually coding happens, this is your starting moment. Like this is like, you can put it like 7:58, right? Then how many seconds would taken? This would get time to time is like current time. It would give you the current time minus start, right? So maybe current time would be 7:58 and some seconds and 16 seconds. It would take 16 seconds. Cool or not? If it is fine, give me a thumbs up, guys. If it is not, you can DM me. Right, folks? I believe you can go for it. Right. Now the thing is, memory. If you just want to see how much memory does a array can take, how much space a list and array takes, and you can just go for it and experiment. So the second parameter I would, you know, space complexity. I would just go for just check the memory, right? So I believe I had an array A. What I name I've given? Okay, I've given the same name. So I'll just copy this. For this, we have a module SYS, right? So this is control. This is my array having from 0 to 1 crores, all the numbers. And get size of, yes, get size of A, right? This is what this array is taking, right? Now I need this list is taking, sorry, this is a list. So again, I took this list is taking is this much space, right? So we are so much into the array that whatsoever I'm saying, it's array only. But I believe you're getting my point. It's not something about the array. I'm talking of here, it is a list, right? Now let me make another array. Okay, so B is equal to NP dot arrange 1000. Okay, 1 2 3 4 5 6 7. Same na 1 2 1 2 3 4 5 6 7. Yes. Now let's see when says dot get size of size of B. So this is taking, now it is looking like they are almost same. Agree? They're almost same. So what is the, why I was saying that array can be more effective. It can take less time. It can take less space as well. Because in array, I have one facility. It is taking this much space, which is almost same like this, due to the default integer data type of collab, which is int 64. But the point is, I can manipulate this in many NumPy. I can change the integer default data type, which is integer 64, to integer 32. Let me show you. D type is equal to int 32, right? And period end. Now, can you see this? It just got reduced to half. And not this. I can also take np dot 16. It got again half. Not even 16. I can even go for 8. Now you can check now. This and this. Almost like 8, 9 times. Less space it is taking. Cool or not? I believe uh, this has been proven. Okay, guys. Is it fine? So I believe you got whatsoever I just want to, convey to you today. And if it is a yes, give me a thumbs up. So that's all from my side, guys. And uh, we would share the same class files to you. And yeah, bye bye. Take care. Enjoy. Any concern, you can DM me. Do not worry. And I believe you're enjoying it. Okay. If not, then okay. That's all from my side. Bye bye, guys. Take care. See you.